Okay, today I'm going to be teaching you how to solve inequalities and graph them on a number line. It's a really easy lesson. The two most important things, well, there's actually three things, but the two most important things at the beginning of the lesson are these two right here. When you see a greater than or less than sign, you use an open dot, and when you see a greater than or equal or less than or equal sign, you're going to use a closed dot. So if you remember those two things, that's about 90% of what you need to learn here. So, the best way to get started on this is just to start doing a few problems. All right? All right, so what we're going to do is we're going to say x is greater than or equal to 5. So how do I graph that? Well, the first thing I do is I look at the sign. Greater than or equal means I'm going to use a closed dot. So what I'm going to have you do is you're going to draw, that'll be 0 on the number line. And then I always, you won't see this in a textbook or anything, but the way I typically do it in my class is I write the 5 there, and I write the opposite, so -5. So in my class, that's all you really need to do is put those three numbers. Put 0, the number, and the opposite of the number, okay? Now, x is greater than or equal to 5, so that means at 5, I'm going to put a closed dot, okay? And a closed dot is shaded in, right? And then you have to figure out which direction is that dot going. Okay, so here's what you need to do here. What you need to do is you need to figure out which side of this graph is going to work. If I put a 0 in for x, is 0 greater than 5? No. So 0 doesn't work, so this is false. If I put a -5 in, is -5 greater than or equal to 5? No. Well, that's false. Let's put a number that's greater than or equal to 5, like let's say 10. If I put a 10 in, is 10 greater than or equal to 5? Yes. 10 is true. It's over here. And what you want to do is you're going to draw an arrow, and that arrow is going to go in the direction of the true. So that arrow is going to go in this direction. Okay? Now what this arrow means is that any number that is greater than or equal to 5 is going to work. And since this dot is shaded, we're saying 5 works also. If I put a 5 into this equation for x, and I'll try this. So put a 5 there. Is 5, you don't have to write this, but just watch it. Is 5 greater than or equal to 5? Is this true or false? It's true. 5 is equal to 5, so it's greater than or equal to 5. And that's why we have a closed dot there, because the closed dot means that the number that it's on also is true. So the dot that it's on is also true. Anything over here is false, the number that it's on is true, and anything past that is true. Now on your notes, you don't need to write that true and false. In fact, you can erase those. But that's the idea behind this line. Anything on the line means true, and anything off the line means false. So pretty easy, right? All right, so let's do another example. Y is less than -2. So in this problem, we'll notice that it's an open dot, right? Because less than or greater than has a open dot. So what I'm going to do is, just like before, we're going to put 0 on there, we're going to put -2 on there, and we're going to put +2 on there. Now if you look in textbooks, they're going to have a full number line, but that's just enough for us, okay? All right, so here's what we want to do. At -2, I want to put a dot. Now the question is it an open or closed dot? Well, in this case, it's a closed dot. I'm sorry, it's an open dot. All right? So it's an open dot there. Now here's the question, which way is it going? We're saying that numbers that are less than -2 work. Well, which numbers are less than -2? These numbers over here. These numbers are greater than -2. So my line needs to go in this direction towards the negatives, right? So that's what direction my line is going. Now, here's a nice little side note you may not be aware of, but another thing you can do here is this. You see this arrow for the greater than and the less than sign? I want you to actually, in your mind, think of it as an arrow. Okay? So you see an arrow here now, right? If the variable is on the left-hand side, that arrow points in the direction that it's going. So see how the variable's on the left-hand side? So that arrow points in the same direction. It's going that way. Do you see that? There's your greater than sign. Is the variable on the left-hand side? Yes. So that arrow is pointing that way. So it's a pretty easy way to memorize it, okay? All right, so in example 3, it's going to get a little bit harder. What you're going to do is you're going to solve this. So just like every problem we've done before, you can solve it like a regular equality. So in your mind when you're doing this, don't think of this as an equal sign and it'll be a lot easier. So I want to get x by itself. So what am I have to do? Well, I'm going to have to add a negative 7 to both sides, right? Right? And I get x is less than or equal to what? 3 plus a negative 7 is negative 4. And then I'm just going to go ahead and graph that. So it's not hard at all. Okay? So graph that. Here's 0. Here's negative 4. Here's positive 4. Now there's two reasons that the arrow is going to go to the left. Is it going to be an open or closed dot? Well, first of all, it's less than or equal, so it's going to be a closed dot. So closed dot, shade that dot in, right? And in which direction is the arrow going to go? Well, in this case, we're saying numbers that are less than negative 4. Less than negative 4 is over here. Also, if the variable's on the left-hand side, this arrow goes in the direction that it's going. So my arrow is going to be over here. Okay? Now, once we get into these algebra problems, we're actually solving them, you need to check it afterwards. So here's how you check. You're going to check it. Sorry, let me change my color here. You're going to check it with a number that works. So you're going to check it. You're going to check it with a number that's less than or equal to negative 4. So I'm going to use negative 10. I'm going to say x equals negative 10. Why did I pick negative 10? Because it's an easy number that's less than negative 4. Okay? And I'm just going to plug that in. Is negative 10 plus 7 less than or equal to 3? Let's try it. Negative 10 plus 7 is negative 3. Is negative 3 less than or equal to 3? That's true, so it worked. If this comes out false, you screwed up somewhere, okay? So that's what you need to make sure you check it at the end. It's going to be a real easy check for you because these problems are not going to be that hard for you. But do check it. Check it with any number that makes this equation true. So any number in the red area. So negative 10's in the red area. That's why I picked it, okay? I like using either 0 or negative 10, some easy number, okay? So let's do example 4. In example 4, we're going to get the variable by itself first, right? So we're going to have to add 2.8 to both sides, right? Okay, we're adding a positive and a negative, so we're actually going to subtract. So what's 3.5 minus 2.8? 0.7, I believe. And be careful because it's negative 0.7. Okay, is less than or equal to y. Now be careful here. If I had, let's say, I'm going to go over here. You can put your pencil down. Don't copy this. If I had 2 is less than x. If I flip these around and I put the x here and I put the 2 here, I don't leave the inequality like that because 2 is less than x, but now x is less than 2. This is wrong. In fact, when you flip the number and the variable around, so if I put the x here and I put the 2 here, the inequality has to get flipped also. So when I put the x here and the 2 there, this has to get flipped too. So this has to go like that. Okay? So if I want to have my variable on the left-hand side, I've got to flip everything around. So that's what I'm going to do here. So I flip it around. Y is greater than or equal to negative 0.7. And that's what I'm going to graph. Here's 0. Here's 0.7. Here's negative 0.7. Determine if it's an open or closed dot. In this case, it's greater than or equal, or in this greater than or equal here. That's a good point. I need to point that out to you real quick. You don't look at this equation. When you're done, you're going to look at your final equation. So we're looking at this now, right? So it's greater than negative 0.7. My variable's on the left, so my arrow goes to the right because that arrow is going to the right. So it's a closed dot because it's equal to, right? And it's going to the right, so it's going in this direction. Going to make a thicker dot here. Give me a second. So my arrow is going in this direction. Okay? And then I need to check it. In a minute, you'll really appreciate why checks are so important. So what I want to do is try a number that makes this true. I don't know if you have room on your paper, but I'm going to do it off to the side here. If you have room on your paper, I have to use these big markers, so it's a little bit harder for me. But if you can write it on your paper, even better, your notes. So let's try that. Negative 3.5 is less than or equal. Now I need a number. I'm going to try a y. I'm going to check it with a y that is equal to something that works. What's a number that's greater than or equal to negative 0.7? Well, 0, right? Isn't 0 greater than that? So I'm going to check it with 0 because it's such an easy number to work with. Okay? You go back to the original equation, so I'm going back to this. Negative 3.5 is less than or equal to what y am I going to use? I'm going to use 0. So I'm going to put a 0 there, minus 2.8. Negative 3.5 is less than or equal to negative 2.8. And that is true. Negative 3 is smaller than negative 2. Because remember, when the negatives, everything gets flipped around. But negative 3.5 is smaller than negative 2.8. So this is true. Everything worked. Okay? And once again, everything on the arrow is true. Everything not on the arrow is false. That's what we're saying with this line. You don't have to draw this up here, but that's what we're saying. Okay? All right, next example. We're going to get the x by itself. So we're going to subtract 5 and 1/6 from both sides. Subtract 5 and 1/6. 2 and 1/3 minus 5 and 1/6. I'm going to change this to 2/6. Okay. 5 and 1/6 minus 2 and 2/6. That's a little bit hard probably for a few of you. But if I'm subtracting these, I'm going to get 1/6 minus 2/6 is 5/6. And that becomes a 4, and you get 2 and 5/6, I believe. So negative 2 and 5/6 is greater than x. So x is less than negative 2 and 5/6. Okay? That's what I'm saying there. Because I flipped the variable around and the letter around, because I want my variable first, because I flipped them around, I've got to flip the inequality also. It was going this way. When I flipped it, it's now going that way. And that's what I'm going to graph. Okay? So I'm going to graph that point. So I'm going to graph negative 2 and 5/6 and positive 2 and 5/6. Now, this would be a good place to graph this on your own. Don't even look at my work. Try it yourself and then come back afterwards and see if you get the same answer at me. Go ahead and pause the video here and try this problem yourself. Okay? All right. So I'm going to do it now. Is it going to be an open or closed dot? Well, it's less than, it's not equal to, so it's going to be an open dot. So we're going to have an open dot there, right? I don't care if it's in black or red, that makes no difference. And then we need to go in this direction, because remember, my variable's on the left-hand side, so my arrow goes in that direction. So it goes in this direction. Okay? Got it? So that's what yours should look like. And then you need to check it, right? All right, so how do you check? Well, remember what I said. You check it, you write check. And you tell me what you're going to check it with. I need a number that's less than negative 2 and 5/6. So I'm going to pick negative 5, okay? I'm going to check it with a number that's less than negative 2 and 5/6. So I'm going to check it with x equals negative 5. Why did I pick negative 5? You can pick any number as long as it's less than negative 2 and 5/6. So let's put that in there. Go back to the original equation. We had 2 and 1/3 is greater than negative 5 plus 5 and 1/6. So let's see what happens here. 2 and 1/3 is greater than, what's negative 5 plus positive 5? 0. Let's make 0 so I have 1/6 left over. So that's what I'm saying. Is 2 and 1/3 greater than 1/6? Well, absolutely. So this is true. So what I just did, it works. Okay? All right. Get into a little bit harder problems. In this problem, we're going to solve it just like before. So we want to get the x by itself. So let's start off by adding 3 to both sides. right? And we end up with 3x is less than 8 plus 7 is 15. And then we divide both sides by 3. X is less than 5. Real easy. How do I graph that? Well, here's 0, here's 5, here's negative 5. Open or close dot, open dot at 5, going which direction? Well, it's less than 5. So the variable's on the left side, the arrow's going this way, so everything's going away from away from the 5. So it is going, wow, that is a really bad line. But it is going this way, right? Sorry about that. Let's make a nice chunky line so it looks decent. So it is going this way, right? Got it? All right. Can I check it? I'm going to check it with a number that works. So I'm going to check it with a number less than 5. I'm going to use 0. So I'm going to say x, check it with x equals 0. So I go back to the original equation. 3 times 0 minus 7 should be less than 8. That's going to be 0 minus 7 is less than 8. Because that's negative 7 is less than 8. Is that true or false? That's true. So what I just said worked. Okay? All right. Now on to the next problem. This one we need to spend a few minutes about. If I was to rank the most common errors in Algebra 1, what I'm about to show you right now is one of them. Okay? You need to be very careful with this. All right? So what I'm going to do is I'm going to do this. Let's start off with an equation that's true. Let's start off with something like this. 5 is greater than 3. Okay? Is that true or false? It's true. 5 is greater than 3. So let's add 1 both sides. So add 1 to both sides. And I get what? Is 6 greater than 4? Oh, it's still true. Well, let's subtract 2 from both sides. Okay? Now I have what? 4 is greater than 2. Is it true? Yes. Still true. Then let's try it again. Let's double both sides. Let's multiply both sides by 2. Okay? 4 times 2 is 8. 8 is greater than 4. Is that true? Yes. Right? Let's divide both sides by, I don't know, 2. Let's say 4. Divide both sides by 4. 8 divided by 4 is 2. Is greater than 1. Is that true? Yes. Now watch this. Now I'm going to take both sides and I'm going to multiply them by a negative 1. I'm just doing random things. Now watch what happens. This is important. 2 times a negative 1 is negative 2. Negative 2 is greater than negative 1. Is that true? Is negative 2 greater than negative 1? No, it's false. So what happened? Every time I did something, I got a true answer. But I come down to here, and I multiply both sides by a negative 1, and it becomes false. It's no longer working. Well, what happened? Well, what happened is one of the most important concepts of Algebra 1 that more people than anything mess up on. What happened is this. Go back to the star, a very important star. Remember, when you multiply or divide both sides by a negative, flip the inequality. That is so important. This is the key to this entire lesson. If you're going to multiply or divide both sides by a negative, you have to flip the sign, the inequality sign. So what does that mean? Well, right here, when I multiply both sides by a negative, right? What happens then is 2 times a negative 1 is a negative 2, and 1 times a negative 1 is a negative 1. But because I multiplied by a negative, this greater than sign becomes a less than sign. Right? And it's a little bit hard to explain why that happens, but the simplest way to do this is this. 2 is greater than 1, but when you negatize both numbers, now negative 2 is no longer greater than 1 because they get flipped on the number line, right? Those numbers get flipped on the number line. And when they get flipped on the number line, right? So if here's 0, here's 1, and here's 2, right? 2 is bigger than 1. It's before it. But when you flip them on the other side of the number line, right? Now negative 2 is actually smaller than negative 1. So that's why you flip the inequality, because that negative actually flips the numbers around the number line and everything gets in reverse. So remember that. When you multiply or divide both sides by a negative, you have to flip the inequality. Okay? All right, so let's do this problem now. Subtract 5 from both sides, or add a negative 5 to both sides, right? Those make 0. We're left with negative 6y is less than or equal to negative 16 minus 5 is negative 21. Is that right? Yeah, negative 21. Okay. Divide both sides by a negative 6. And then right here, I would do it in red or I would do it in something, right? I would write an arrow to this. Be careful. Why do you have to be careful there? Because you just divided both sides by a negative, and when you do that, you've got to flip the inequality around, right? So when I do that, I get y, and because I divided by a negative, I flip the inequality, and negative over negative is a positive, and 21/6 is really 7/2, I believe. So 7/2, or if you want to, you could call that 3.5. Okay? Whichever one works better for you. But what's the key here? Right here, that inequality gets flipped, right? Because you just multiplied by a negative. And if you want to, you could put an arrow to both of those. So you could put it there and put it there. But that's what you have to be careful with. That's the hard part, okay? All right, check it. And when you forget to do this, if you forget about flipping the inequality, what will happen is when you come to your check, it's not going to work, okay? But I'm going to check it with a number greater than 3.5. So how about 10? I'm going to check it with 10 because I know that's greater than 3.5, right? So I'm going to check it with 10. So negative 6 times 10 plus 5 should be less than or equal to negative 16. Well, negative 6 times 10 is negative 60. It's a big negative number. Plus 5 should be less than or equal to negative 16, right? Negative 60 plus 5 is negative 55. Is negative 55 less than or equal to negative 16? That's true. It's correct. So I can graph that. I could have graphed it first, but when I get into those negative ones, I would probably check it first to make sure everything's working. Okay? Is it an open or closed dot? Well, it's less than or equal, so it's a closed dot at 3.5. So I'm going to write it up here, 3.5, negative 3.5, right? Open or closed dot at 3.5, going which direction? Well, going to the right, yeah? Here, what's the true reason that it's going to the right? It's going to the right because it goes towards the check, and it goes to the right because the variable's on the left-hand side, and so this arrow goes in the same direction as that arrow. Okay? Got it? All right, we're down to a couple more examples. In this problem, we're going to have to first get rid of that negative 1/4. Now you got two options. You can distribute it, or you can start off, which is the way I like to do this, and multiply, oops, and this in red, I don't want red. We can start off by multiplying both sides by a negative 4. So I'm going to do that. I'm going to multiply both sides by a negative 4. Okay? Now the question is, do I multiply this and this by a negative 4, or do I just multiply this by a negative 4? All right? Some people will multiply this by a negative 4 and multiply all this by a negative 4. And that's actually not what you do. And I can prove it to you. If I had 2 times 3, and then I multiplied it by, let's say, negative 4, do I multiply the negative 4 times the 2 and the 3, or just one of them? Well, the answer is just one of them. So that's what I'm doing here. It's a number times some weird number, but it is a number. A number times a number times a number. I only multiply the negative 4 times one of them. So a negative 4 times negative 1/4 makes 1. So I'm left with 1 times p. So I'm just left with p minus 12. Nice, right? Got rid of that fraction really quickly. Got to be careful here. I just multiplied by a negative, so this inequality gets flipped. And negative 2 times negative 4 is 8. Add 12 to both sides. right? And we end up with p is less than 20. Check it. Give me a number that's less than 20. How about 30? I'm sorry, how about 0? What's a number less than 20? Not x, right? P. P is 0, right? Because 0 is less than 20. Let's check it with 0. Negative 1/4 of 0 minus 12. Dang it, 12. 0 minus 12 is greater than negative 2. And remember, when I check it, I always go back to the original problem, right? That's what I'm going to do. So 0 minus 12 is negative 12. Negative 1/4 of negative 12 is positive 3. Is 3 greater than negative 2? Yes, it's true. So that's good. And that's what I'm going to graph, right? Here's 0. Here is 20. And here is negative 20. Now, two reasons it goes to the left. It goes to the left because the variable's on the left-hand side, so this arrow goes in the same direction. And it goes to the left because it worked for 0, so it goes towards 0. So open or close dot, open dot, right? Going which direction? Well, to the right, right? Sorry, to the left, towards the arrow. So it's going to go this direction, right? Got it? Not too bad. By now, this is probably making sense to you. It should not be that hard for you by now, okay? Getting into a little bit harder ones. I know this lesson's gone long, but we've probably break this lesson up over 2 days. So this would be part of the second day lesson. But let's go ahead and do that now. What we're going to do here is just like every other problem, we're going to just solve it. I'm going to start off by distributing that 3, okay? And I end up with 14x plus 5 is less than 15x plus 15, right? What I would recommend you do is I would bring the 14x over here so I don't have negative x's. Because if I have a negative x here, then I'm going to have to divide by a negative and flip this inequality. So I would rather bring that 14x over here than to bring the 15x this way and end up with a negative x that I have to then flip the inequality. So that's what I'm going to do. I'm going to bring the 14x over, okay? You can do it the other way. Just remember to flip your sign. Minus 14x, right? I'm left with 5 is greater than x plus 15, right? Add a negative 15 to both sides. You're left with negative 10 is less than x, or x is greater than negative 10. Okay? For the sake of time now, I'm not going to check this, but I will graph it for you. Here's 10, here's negative 10. Open dot because it's greater than, open dot at negative 10. And it's going towards, it's bigger than negative 10, so it's going towards 0. So it's going to go this direction, right? Okay? Got it? That's probably a little bit fatter of a line than I wanted, but oh well. Got it? All right, so let's do the next one. All right, the first thing I would start off with is getting rid of that. I would combine this negative 1x and this 4x. What's 4x plus a negative 1x? Well, 3x. So I have, oh, wow. Let's change this on, change the color again. All right, so what I want to do here is 4x plus a negative 1x is 3x. So I have 3x plus 3, and this is going to be greater than or equal to 3x plus 7, right? Then I'm going to subtract 3x from both sides, or add a negative 3x to both sides, and I'm left with 7 is greater than or equal to 3. Now, what the heck does that mean? Well, what this means is, this is a special problem, and it's kind of neat to look at for a minute, because what this means is the x's went away, okay? And what this means is 7 is greater than or equal to 3. Is that true or false? It's true. 7's always greater than 3, right? This is true. What this is saying is that there is not a number that I can put in for x that does not make this true. The variables went away. I'm left with two numbers. If the two numbers are left, if what's left is false, let's say it said 3 is greater than 7. Is that true? No, it's false. If it said that, there's no number that would work. But it said this. If the variables go away and whatever's left is true, then guess what you shade? You shade the entire number line. What you're saying then is you're saying every number works. Okay? So you would shade the entire number line. There is not a number that you can put in for x that doesn't work. And that makes sense because let's look right here. When we combined the 4x and the negative 1x, I had 3x and 3x. Whatever I put in here is going to be equal to this, right? Well, this is always going to add 7. This is always going to add 3. So this will always be bigger than this. There's not a number that you can put in here that doesn't make this more than this. They both have 3x. You're adding 7 to this, and 7 is always more than 3. So you shade the whole thing. Okay? All right, 2 more examples, and then we're done. In this problem, we need to first figure out what we need to know. Well, we're trying to find the area of this shape. And we know that the length is x plus 1 and the width is 9. And they're telling you the area is less than or equal to 54. Well, we know that area is equal to length times width, right? For a rectangle. So we know that the length, 9 times x plus 1, is less than or equal to 54. This is the length, this is the width, or this is the length and this is the width, however you want to look at it. But you're multiplying those two things and they have to be less than or equal to 54. Now you could distribute the 9, but I'm going to start off by dividing both sides by 9 because it's actually easier. X plus 1 is less than or equal. 54 divided by 9 is 6. I would not divide by 9 if this wasn't a multiple of 9. I would actually distribute the 9. But since this is a multiple of 9, it's better to divide first. Okay? And then I would subtract 1 from both sides. And I get x is less than or equal to 5. Okay? You would check it and everything else just like before. It's really easy to graph. Here's 0. Here's 5. Here's negative 5. Okay? Numbers less than or equal to 5, right? So numbers less than or equal to 5. Well, open or closed? Closed. Which numbers are less than or equal to 5? Well, 0 is less than or equal to 5. Also, is the variable on the left-hand side? Yes. So the arrow goes in the direction that it's going. This arrow is going this way, so my arrow is going to go this way. Let me change it to red real quick and make it a little bit thicker. So my arrow is going to go this way, right? Okay. No problems there? All right. Last problem, and then we're done. All right, in this one, this is a triangle, right? And we know that area of a triangle, area equals BH over 2, right? On a side note real quick, the reason it's BH over 2 is because we're saying turn it into a rectangle, right? If I squared this off, it'd be a rectangle, and it'd be length times width, but you only want half of that rectangle. That's why you divide by 2. All right, so this is what we're going to do. We're going to have base times height. 6 times that is less than 56, right? I would real quick check is 56 a multiple of 6? It's not, so I'm going to distribute first. So I would not divide both sides by 6 because this is not pretty. That'd be 12x plus 6 is less than 56, right? Now I'm going to subtract 6 from both sides. And I have 50. And I get 12x is less than 50. I'm going to divide both sides by 12. And I get x is less than, let's see, what is that, 25 over 6? Right? And that's what I'm going to graph. Here's 0. Here is 25 over 6. love fractions. I don't have to care where they are. This is negative 25 over 6. 25 over 6 is about 4, right? So it's around 4. But it's going, the left arrow's going this way. The variable's on the left-hand side, so this arrow is going this way. Open or close dot, open dot, going to the left. All right. There you have it. Graphing inequalities on a number line. Remember, the three big ideas on this entire lesson is the open and the closed dot. And make sure that when you multiply or divide by a negative, you flip the inequality. All right, good luck.